Hello, displacement time graphs. Now, displacement time graphs, why do we do them? Because it's often convenient to represent motion on a graph. It can convey a lot more information than just numbers or sentences, and if you're conveying that information, we need to also be able to extract information from these graphs. So it's good practice. Hopefully most of us have had some practice at reading graphs, and we're just putting some more interpretation onto it as is necessary. Now, there are distance time graphs and displacement time graphs, even though this is up here, displacement time graphs, and the difference being that, of course, you're plotting distance versus displacement, and we've just covered the difference between distance and displacement, and that has important consequences because we need to know what sort of graph it is to interpret it correctly, and it also changes something that we're just about to look at in a couple of dot points. Now, generally speaking, they would have the motion of the object with time on the horizontal axis. Yeah, just time on the horizontal axis, and you either have displacement or distance on the vertical axis. And the slope on a displacement time graph gives you the velocity, and we'll look at that shortly. And so what do you think the slope on a distance time graph gives us? It gives us speed, and that's a very important interpretation. So you need to be, when you're looking at a graph that's describing motion, you need to know which sort of graph you're looking at, and usually it's given to you on the labels, because that changes your interpretation and what you're actually saying about it. Now, what does this data tell you? Here we have time elapsed in seconds and displacement in meters. After 1 second it's 10 meters, 2 seconds 20 meters, 3 30, 4 seconds 40. Alright, seems pretty straightforward, and every second it's going a further 10 meters away from its starting position. Now that's pretty simple data to interpret, but what would it look like if we graphed it into a motion graph? Look like this. Now notice we've got a nice label here, displacement, meters, and time in seconds. And if you're doing your maths, you'd recognize that this would be the x-axis in Cartesian cartography, is it? Or a Cartesian axis. And this would be the y-axis. And they're all nicely labeled, and we've plotted our data points here. And that describes this motion here. So we could interpret that. Now remember back to the previous slide, what's this slope represent? Well, it's a displacement time graph, so the slope represents velocity. And how would we work that out? Well, we would draw, hopefully we've done this in maths, we might draw a nice big triangle there. That would be our run, and we draw a nice arrow going here, going up, because we always go from the start position to the finish position. So that's going that's a rise, and so the slope equals rise over run, and in this case, what's that? 50 meters divided by 5 seconds. Now notice we've got meters divided by seconds, so that will tell us what our units are, and 50 divided by 5 is 10. So what is it? It's meters per second, or it could be written as 10 meters per second with the seconds as the -1, meters seconds to the -1, because raising something to the power of -1 is the same as having it divided by. Yep, sort of. That's where that -1 comes from. So hopefully we're good at that. Now some students, when they asked to do the slope, they draw a triangle like this, okay, and a bit straighter than that. Well, maybe they didn't even use a ruler. They do a tiny little triangle, and they don't make use of the graph paper. See here, I picked a point that crosses the lines, and I picked another point here which intersects lines, so it makes it much more easier to read these lengths of these sides accurately. And the bigger the triangle, the more accurate you'll be. Just something to be aware of. But you probably already know that. Right, let's move on. Now, what do these graphs mean to you? Here we have time, and we've got a black axis, and we've got displacement, and the red line represents the motion. So what sort of motion is this graph describing? Now, we don't have any units, so it's a very general, it's a sketch, but we can still say something about it. Now notice that the displacement also has minus displacement. That's because displacement can be positive and negative. Up can be positive, down can be negative. East can be positive, in which case west would be negative. We can do that with displacement. Now what's happening in this case? Well, the object started at the start position, which we assume to be the origin, and has been there as the clock has ticked. So what do we got? Stationary at the origin being 0, 0. What does this one describe to you? Well, the object is at Y from the origin, but it stays there. As the clock ticks, tick tock, tick tock, tick tock, tick, it stays in the same position. Therefore, the object is stationary at a distance Y from the origin. That's pretty straightforward. Not much motion happening there. What about this one? A bit trickier. What's happening here? Well, the object starts at a position away from the origin, and then as the clock ticks, it moves further away from the origin. Notice that this is a straight line as well, so it's moving at a constant rate away from its starting position. Moving at a constant speed. Strictly speaking, it's moving at a constant velocity, but we can let that one pass. What about this one? Starting and then it's moving, but it's no longer at a constant rate because the slope here is getting steeper and steeper. And if you do maths, you recognize that we could measure the slope here by taking a tangent, and the tangent at any of these points is getting steeper as you move through as time passes. And so this object is accelerating, which sort of gives away what this one might be doing. Here the object is coming back towards the origin, but it starts off coming back fairly quickly, and then it's slowing down. So there it is, decelerating. So this is accelerating, this is decelerating. Now remember, this is a displacement time graph. In the next video, we'll start looking at speed and velocity examples to try and just bring it together a little bit more. Farewell!